There will be a special technical direction in the future. Is operator technology. Then you will find it is not a technical system with the enterprise network. So for us now, you can remember this. The above is the public network. Then export this device. When docking with operator equipment, this address must also be a public address, because the company's people are going out to the internet. Then the package needs to be returned to the device. Otherwise, there is nowhere to find the message. I can't pack it back. So it has to be a public network too. But for the following, such a network range, there are multiple users inside. Then these users can use the private address. This is the address that every company can use. The future is exporting here. It will do a conversion between the private network and the public network. Now only guarantee. This private address is not repeated internally. Because now there is internal communication. Can't share the same name with other people. But in the future when we export, a technique called NAT can be used. Put this through a conversion. Convert this private address to a public address. Then go out and go online. After the network finally responded. Then configure the NAT device by this. Convert this address to a private address. That is to say, this is equivalent to the internal and external network. It's two completely different systems. We can use private addresses internally. When people are online, transfer to an external public network together. Then it goes to the public network. So then, since every unit, every organization and institution can be used internally, but it won't repeat. For example, we can all use 192.168.1.1. Every household has this address. Why not repeat? Because when we finally access the public network, the converted address is a public address. It will not repeat. But within each organization, the private address used is randomly repeated. Because they do not communicate. Even if there is a need for mutual visits in the future. That is also the demand from the public network to the public network. Because only the final data traffic reached the peer device. It only knows that the NAT is going down now. Actually, we all access the public network from the public network. That's how we look. At least from the looks of it. Then inside, we do such a conversion between technologies. Unlimited things can be done with limited addresses. You will find that your company originally 100 people occupy 100 addresses alone. It's different now. Can now be allocated 100 addresses available to all companies. Equivalent to the end user problem solved. We only need to ensure that the current public address, when the user comes out, it can be converted smoothly. What we actually use now. Such a technology. If the current Google address is 7.7.7.7, it has a mask that is 24 bits. Then can I configure a 7.7.7.7 for the internal device now? Okay. This address is configurable. The reasons are as follows. First, it conforms to the configuration specification for IP addresses. It must be connected to the device interface. Second, for example, you assign 0.6 to the one on the left. This is 0.5. This gateway is 0.1. 7.7.7.1. There is no problem with communication between you. If the current public address is 123.11.2.3, there is no problem. After you have allocated this address now, it will be a rather embarrassing thing. Due to your current address and Google's address. Then when you encapsulate the data, by default, it will consider this to be an address on the same network segment. How are you sending the package now? The source IP is yourself. The destination IP is also your own. The source IP is the same as the destination IP. This message is in terms of the entire communication format. Is not possible. That is, I want to send myself a package. Then the default package will not send out the interface of this device. Because once this interface is assigned an address, that is, once configured with 7.7.7.7, a message will appear on your device. 32-bit host routing generated on your device. Because the device thinks this is you. To visit yourself. So it will not outsource. This is the first question. The second question is, if your address is weighted, does not affect the internal communication between you and others. Intranet is accessible. But this 7.7.7.6 on the left, when it wants to visit, source IP is self. The destination IP is 7.7.7.7. It wants to access Google. But since now when visiting, this device is computed locally, we will find that this person is on the same network segment as me. It thinks we're both on the same network. So it is directly communicated internally. It will send the data directly to you. It doesn't know I'm going to visit Google now. Because I am on the same network segment as Google. I thought we were on the same network. On a logical link. I'll just send it to Google. Google got it. That for you now. I can't go online. But that's not to say it's absolutely impossible. If now Google is not 7.7. It is 11.1.1.1. This is also a public address. But you are still using 7.7. That's fine. Such a public address can still be used internally. Now everyone can communicate with it. Because of the exit, this will convert the address to 123 of the exit. It's okay. But make sure. Internally, if a public address is configured, you have no way to access the future URLs on the same network segment as you. That is, address conflict URL. Second, all other equipment. As long as there is a need to access the outside world, then it is inaccessible. You can configure, but you can't guarantee. Will this configuration affect other people's internet access? Because we are online now. DNS is used. We are all analyzing. You don't even know the destination server you are accessing now. Which network segment does it belong to? You can't promise yourself not to repeat it. That's why we can configure it. Can also pass. But why it is not recommended to do so? Some students will ask. Why does the configuration of the private network not repeat? Because it is absolutely impossible for a private IP to appear on the public network. That's why it made this painting a private network. It is specially designed for you to configure in the private network. Can guarantee you absolutely access to the public network. There is no problem. Because it can guarantee. There is absolutely no device on the public network that will configure a private address. You can configure it like this. Then the DNS needs to be changed accordingly. Because for intranet devices, just such an address. First, make sure other devices can't think the server is you. Second, for external devices, except in your intranet, no one knows you are at this address. So can you configure this? It doesn't matter to the outside world. You just have to guarantee. There is no internal conflict. Because to the outside world, now this is an internal. No one cares who this is. In the end we are all going to perform NAT. That is, when we connect to the carrier, one address is enough. It can meet the current needs of internal internet access. Then for the private address, it has a stipulation. That is, Range of private addresses. Everyone will find. I am from the ABC 3 types of addresses. Cut out a piece. As private address. Everyone can see. First of all, the first one belongs to the Class A address. From 0 to 127. The second is to cut out a block in the B class address. Because Class B addresses are from 128 to 191. It is 172. And a block is also cut out from the Class C address. In fact, these 3 types of private addresses. It is possible to distinguish small, medium, and large corporations. Generally for small businesses, Class C address segment is sufficient. For medium-sized companies, if Class C is not enough, use it together with Class B and Class C. Large enterprises directly use Category A. You will find it more variable in number. Class C address segment can be changed to a smaller range by default. So let's summarize the 3 types of ABC addresses. Looks like we can all use. But actually on the internet. That is, when we are going to network. We really have a unique IP address on the public network. You want to remove the special address. And remove the private address. Because private addresses are generally used by internet users. Not available on public internet. So you have to rule out the private address. The rest is what can really be configured on the interface. Unique IP address. Next we have to mention another concept. Subnet mask. For the IP address we just talked about, the following is suffixed with a subnet mask. Why is there such a suffix? Everyone can see. When I was showing the network card just now, this IP address has a subnet mask under it. There is a correspondence between them. Let's see how they look first. The first to discover. They seem to be similar. Both are dotted decimal. So let me ask you a question now. For example, now there are 2 devices. Each device is configured with an IP. Can they communicate? For example, this device is configured with 192.168.2.3. Another device configuration 192.168. 1.2. Can they communicate directly? Okay. It depends on the mask. You want to know if you can get through. You can't tell just by looking at the address. We have to combine another parameter. Mask. Because it is possible to communicate directly. This is to have a network segment division. You may have heard a sentence. Direct communication on the same network segment. Different network segments cannot communicate directly. So we can't just look at the address. Let's look at the network segment. So we have to combine another parameter. Subnet mask. Only after combining the subnet mask. The classification of IP addresses has the greatest significance. It can constitute all the information used on a real network card. After IP address classification, 3 ABCs actually define different address ranges. That is, subnet mask. Then I will add to you. For class ABC, in addition to defining their current value, they also define their respective masks. The mask of Class A is 255.0.0.0. That is to say, Class A address defaults to a 8-bit mask. That's the same for the BC class. The Class B address mask is 255.255.0.0. It defaults to a 16-bit mask. The Class C address mask is 255.255.255.0. It defaults to a 24-bit mask. This is the default. I will give you a simple demonstration. For example, I'm going to be on my NIC now. Go configure it. This address is supposed to be automatically assigned. I now want to manually write an address to it. Let's first write a class A. For class A, we will write according to the private address. Now let's say we're configuring the address right now. I am writing a 10.1.1.1 here now. Watch carefully. I do not configure the mask. Just hit the tab key. Make it wrap. Everyone will find. It automatically adds 255.0.0.0. Because what I'm writing now is a class A address. Although it is a private address. But it automatically writes me a mask. For example, I write a class B address. 172.16.1.10. Hit the tab key and you will find. I have to delete this first. Everyone can see. It automatically fills me with 2255. I will now write another class C address. 192.168.1.12. Let's not click OK now. Because I don't have a gateway configured right now. If I now change the overall address and gateway, I'm disconnected now. Because I am using a default assigned address. And after I change the address, may conflict with other equipment in the company. After I hit the tab key now, everyone will see. 3 255s are now filled by default. This is equivalent to, for such an address, our equipment will automatically identify which address range it belongs to. It stands to reason. This 192.168.0.02, 192.168.255.255. By default it belongs to the address range of class C. And the mask is 24 bits. Then when you configure a class C address on the device, it will automatically match your mask. We call it classed. It is divided into ABC 3 categories. So for the address, it must be seen in conjunction with the mask to make sense. The subnet mask can define two parameters. It can define parameters of network bits and host bit parameters. This is what it does. We use a form of IP address plus mask. You can define a range of network segments. Then after defining the network segment, direct communication between the same network segment. No direct communication between different network segments. How to define it?